Hello everyone, I am Grant Dorr and I would like to share with you my presentation over the Pythagorean Theorem. In this video we are going to be demonstrating just how the Pythagorean Theorem works and the equation itself, a squared plus b squared equals c squared, how it connects to the actual areas of the squares that we create with the triangle. So we begin by taking a look at this triangle that we have created. We have A, B, C. We have the right angle there at angle C. And notice it's a right triangle. Pythagorean theorem only works if it's right, and for the following reasons. If we look at just the equation of the Pythagorean theorem, it's a squared plus b squared equals c squared. Now when you hear a squared, as a geometry student, hopefully you're thinking a squared, okay, that's a formula that we can use to find the area of a square. And our a value happens to be the variable for one of the sides of the triangle. Here we're looking at side BC, which is opposite angle A. That's going to be our A. So what we have here with this red square is a square that is based off of the length of that side A. Similarly, we're looking at side B. We have another square. This square is, I have a couple of different shapes making up this square, but both sides are length b. And again, to find the area of that square, b times b is b squared. So that's where that's coming from. So the point of this thing is, again, looking at the equation of the Pythagorean theorem. A squared plus b squared equals c squared. We're looking at the left-hand side of that equation, the a squared plus b squared. According to the equation, what that means is I should be able to take this square that is developed by a, and combine it with the square here of side B, b squared, b by b. And I should take those two areas, and it says that it should be equal to the c squared, which is the square that's formed up here by the hypotenuse. So with the GeoGebra file, I'm just going to go ahead and walk it through it with you. We start with the red area, which is the a squared. We're going to take a copy of that square, and we're going to go ahead and rotate it into that c squared. And now notice the white space, we got a little bit of area that's not filled in yet. Our goal is to be able to take that pink, purple, green, and orange area and somehow fit it into that c squared. Let's see if we can do that. If we click on that pink region and we take that section of the square out, notice it fits perfectly there into that region. If we take a look at the green region, we're going to go ahead and place that region there. The blue region fits as so. And last but not least, if you don't see it already, the orange region is a little square that's left over. And as we rotate it, voila. Notice that all of the b squared, even though we chopped it up into some smaller figures, it does fit within our c squared. And notice this is going to be true irregardless of the orientation or the size of that right triangle. All the pieces fit perfectly into that square. So once again, a squared plus b squared. If we take those two areas and we add them together, sure enough, we get the area that's created by the square with the length of c. Hope you enjoyed the video. Hopefully you got something out of it. We'll see you next time.